We're going to start a new topic, which is geometry. This one is a bit extended, but the concepts are really, really basic. We'll start with lines, angles. We'll see what we mean by parallel and perpendicular lines. Angle properties, look at the type of angles, angles on parallel lines. So if you have two parallel lines, let's say, how many types of angles can be formed on two parallel lines? Perimeter, we're going to talk about area of rectangle, triangle, parallelogram, trapezium, and we'll talk about volume. Okay, number one, lines. What do we mean by a line in geometry? Well, in geometry, uh, we have three types of lines. Okay, this is what we call just a line. So it is, if you, I hope you notice that this is infinitely extending on both sides. There's an arrow on this side and there's an arrow on this side. Okay, so it just keeps on going forever in this direction and keeps on going forever in the other direction as well. Okay, now if you take a small piece of out of this line, for example, you cut a line from here, you cut it from here, then this is called a line segment. This is not a line, but a line segment. Okay, I hope you understand the difference. A line is something that goes infinitely in both directions. It just keeps on going on and on in both directions. It's infinite on both sides, while a line segment is finite from both sides. And the last thing that we see over here is called array. Array is something which is uh, finite from one side, like limited on one side, but on the other side, it just keeps on going on and on. For example, sun rays, right? Whenever we draw sun rays, we used to draw sun rays, and when we were kids, that's how we used to draw it, I'm sure, like this, in our small little diagrams of sun. That's how we used to draw sun rays, right? So I hope you notice that this line originates from the sun and keeps on going forever in the other direction. So these are basically three different types of lines: a line segment, and a array. Array is something that has an arrow on one side. It's an arrow on both sides, and line segment has no arrows. Okay, I don't think I need to write definitions. The next we have is you see these 3 points: point A, point B, point C, point D. They all lie on the same line. Okay, so you can, for example, if I were to draw a few points, if I were to run a line through it, then they all would lie on the same line. Then I would say that these point A, B, C, and D are collinear points. This word is really important. Collinear points. When we say collinear points, we mean these are the points which share the same line. The word collinear. What about these 3 points? X, Y, and Z. They do not share a line, right? Maybe X and Z can be collinear. X and Y can be collinear. They can lie on a single line. Y and Z can be collinear, right? But if you talk about all three, X, Y, and Z, then they are non-collinear because they do not lie on a single line. Okay. X, a, like A, B, C, and D are collinear points. Similarly, X, Y, and Z, all of them are non-collinear points, right? The points that lie on the same line are called collinear points. Next we have is yeah, I hope you see these three lines. I'll call it line L1, L2, L3. Okay. Now all of these 3 points have something in common, and that is they pass through this common point. Okay. If the lines that pass through a single point, those lines are called um, concurrent lines. The lines that pass through a single point are called concurrent points. So you can write a definition. I'll write it. Concurrent lines. Please do not confuse the collinear and the concurrent. When we say collinear, we mean the points, not the lines. Okay. Collinear are the points, while concurrent are the lines. All right. If two or more lines intersect at a point, right? Then those lines are called, they are called concurrent lines. Concurrent lines. Okay. So collinear points and concurrent lines, please do not confuse the two terms, right? Concurrent are always the lines, and collinear are always the points. Then we have parallel lines, right? So we have the lines, two lines that run parallel to each other, but they never really meet each other, right? They just keep on going forever, but the distance between them remains the same, and they never meet each other. Never meet each other, right? If the lines are not parallel, they will always have a point of intersection, right? So for example, if you have these two lines, right? Let's say these are the two lines and they're not parallel lines, right? Here is a line and here is a line, right? Of course, they're not parallel lines, right? Non-parallel lines. If they're not parallel lines, they will meet at some point. And I hope you remember that this is a line, right? So it keeps on going infinitely in both directions. So if I were to extend this line, and if I were to extend this line, I hope you can see this point of intersection of the two lines. This is a point of intersection. Okay. So lines are either parallel or they are intersecting. If they're not parallel, they will always intersect at some point. Okay, let me write down the definition. So parallel lines parallel lines are lines which are always fixed distance apart. So the distance between them is fixed, right? And they never meet each other. This is important. They never meet each other. Again, of course, if the lines are not intersecting, if the lines are not parallel, they are intersecting always. If the lines are not parallel, I'm talking about 2D, they are intersecting, okay, in 2D. Don't have to worry about 2D. Anyway, so let's draw these diagrams. Draw a diagram for each segment. X is a point on PQ, which means we have a line segment PQ. If you have these brackets, you don't have to worry about these because in the exam I'll give you, for example, in this place I'll write line segment PQ. So you have a line segment and you're supposed to draw a point X. This is pretty simple. Draw a line segment, name it P and Q. Make sure that if this is a line segment, it has points in both. And X is a point on this line. X can be any point, anywhere. You can draw it anywhere you want. So line segment PQ and X is a point on this line. Okay, take a look at part B. EF, so this is a ray. Okay, and this is a line. Okay, I'll give you in terms of rays and lines. So if this is a ray, EF is a ray. I'm going to draw E and F is a ray. And there's another line which is GH. So I'm going to draw, you can draw it, I mean, you can draw it like this. It's totally up to you. It's a line. When we say it's a line, it's going to have arrows on both sides. And then its name is G and H. And they meet at point M. So you can draw point M in the middle. And that's point M. Okay. Part C, S, T, U, and V are collinear. So what you can do is draw a straight line, right? And they all lie, for example, on a straight line. So S, T, draw them like points. S, T, U, maybe you can draw V a little further apart. You can draw them anywhere you want. As long as they're on the same line, they're collinear. J, K, and M, N are parallel, and these are lines. Line, and this is also a line. So this is a line that is J, K. Here is another line, which is, I'll give it a name, M, N. and they are parallel. I hope you can see that they're parallel to each other, right? How you can draw it on a paper is you can keep a scale, right, a ruler, and draw a line on this side of the ruler and this side of the ruler. Right? That's the perfect way to draw two parallel lines. Okay, you can name them JK and LM. Right. Next, AB. So AB is a line segment. I'm going to write line segment. CD is a line, and EF is also a line. Okay. They're concurrent at point G. I'm going to draw. So we have AB as a line segment, A and B is a line segment, CD is a line. So it's going to have arrows on both sides, C and D. And we have EF. So let's say there's another line, which is EF, right? And the reason that I drew this a certain way, because they are concurrent at point G, and they pass through, all of them meet at a single point. All of them pass through a single point, which is point G. I hope it gives you a better idea. But parallel lines, concurrent lines, collinear points, and so on. And so we're done with lines. We're done with the first topic, and that is lines. Let's move on to the next one, and that is angles. This is pretty basic. I'm sure you've done it in earlier grades, in smaller grades, grade 7 or grade 9. I'll review it for you. Types of angles. So let's say that, and this is really small. I'm going to start from here. Okay, it should be bigger. Wait a sec. I can make it bigger. Anyways, you can see it. Okay, I'm gonna, point A is a fixed point. Okay, and I'm gonna start rotating point B. So take a look. If I keep on rotating point B, at this point, if I keep on rotating, this is an acute angle, right? And we can see the angle as well, 20.84 degrees. I'm gonna keep on rotating it till it reaches, at this point, this is called 90 degrees. 90 degrees, the angle is called the right angle. Okay, so between 0 and 90 degrees, the angle is called an acute angle. Okay, the angle of 90 degrees is called a right angle. Right? Let's move on. Let's see if the angle is greater than 90 degrees. So if I'm going to make it bigger, and I hope you see the change in the name. This is called obtuse angle, right? Keeps on going until it reaches 180 degrees, right? So the angle that is between 90 and 180 degrees, it is called obtuse angle. Any angle that is between 90 and 180 degrees is called an acute obtuse angle. I'm going to move it even further. Now this is called a reflex angle, right? So between 180 degrees, and it's going to keep on going until you, between 180 degrees and all the way up to 360 degrees, they're called reflex angle. Okay, so acute angle lies between the angle that is between 0 and 90 degrees, that is an acute angle. Exactly at 90 degrees, you have a 90-degree angle that is called the right angle. As you can see, this is a right angle, right? And between 90 and 180 degrees is called obtuse angle. An angle of 180 degrees, if you have an angle that is exactly 180 degrees, it's called a straight angle. Okay, now I'm going to move it. I hope you can see this is a straight angle. Okay, this is super important to remember. Let's take a bigger picture. So if you have one complete turn that is 360 degrees, right? If you start from a certain point and you would take one complete round trip, that is 360 degrees. I'm going to write it over here, right? If you have one half of a turn, that is 180 degrees. Of course, you'll divide 60 degrees into a half and you'll be left with 180 degrees, right? A quarter of a turn, I hope you can already tell, this is 90 degrees. 1/4 of a turn are 90 degrees. If angle that is less than 1/4 of a turn, so remember, 1/4 of a turn is 90 degrees. Any angle that is less than 1/4 of a turn is called an acute angle. This is right angle, right? So if an angle that is greater than the greater than 90 degrees, and this is between 90 degrees and 180 degrees, right? So this is called obtuse angle. Okay. As long as it is before less than 180 degrees, it's an obtuse angle. And this is, of course, once it crosses a straight line and bends in this direction, this is called a reflex angle, because this has now increased 180 degrees, right? Starting from here all the way up until here is 180 degrees, and if you go even further, it becomes a reflex angle. Next, let's give them names, these angles names. So name the shaded angle using 3-point. This is important, 3-point notation. Let me walk you through what do we mean by 3-point notation. 3-point notation is when you write 3 alphabets and you make sure that the angle is in the middle. Okay, I'll give you an example. For example, L, how would I name this angle? I'm going to write L, M in the middle because the angle is at M, right? And I'm going to write N over here. You can write it the other way around as well. You can also put this name, this cap, which means the angle is at M. You can also write it the other way around. You can start from N, right? You can still have M in the middle because the angle is at M. You can write L. They both really mean the same thing. So let's start off by naming this angle. You can name it as angle PQR because Q is in the middle, or you can also name it as RQP. Really mean the same thing. Which angle is it? I hope you can already tell this is acute angle because this is smaller than 90 degrees, right? If it were this angle, this was 90 degrees, but this is smaller than 90 degrees. This, you're starting from here and you go all the way over here. This is 180 degrees. You can also call it a straight angle. And you can also give it a name. You can say starting from A, right in the middle, you have O, B. You can also name it as BOA, and you can keep this thing, the cap, at the central vertex. We've already given it a name. This is, and of course, it is an acute angle, right? This one, you can say it's either SOT or TOS. Same thing, right? I'm going to write it this way. TOS. And the angle, we can already tell that if it were this angle, right, starting from here, ending all the way up to here, this would have been 180 degrees, right? This has definitely increased, surpassed 180 degrees. So this is a reflex angle. Okay. This one, part E, you can give it a name. So I'll let you, I would encourage you to take a pause and start and try naming it by yourself. You can say it's either C, D, E, or you can start from E. So it's going to be E, D, C. And this thing in the middle shows that it is 90 degrees. The square that you see over here, which means that this is right angle of 90 degrees. Okay. Uh, hmm. Without using a protractor, hence classify the angle as acute, right, or obtuse. So what angle STU? Angle STU would mean starting from S, T, and U. So here we can see this is the angle, right? What's the measure of this angle? This angle is 25 degrees. And acute. I'm gonna just write A, acute. Okay. Let's talk about part B, WTU. I'm gonna start from W. So WTU. Okay, this is interesting. WTU has two angles in the middle. It is 63 degrees plus 27 degrees. I'm going to add them, 63 and 27, 6, 7, 8, 9, right? 90 degrees. 63 plus 27 is 90 degrees. So WTU is 90 degrees and the name would be right angle. Okay. Because have you noticed W starting from W, T, and U. WTU has two angles. It has 63 degrees, and it has 27 degrees. So I'm going to add both of them. STW, okay, starting from S, where is S? STW. It's capturing, I think, three angles. STW, it has 25 degrees included, 63 degrees, and 27 degrees. 15, 6, 10, and 11. 115 degrees. It's 115 degrees, so it's going to be an obtuse angle. Okay, I hope it makes sense so far. So we're done with discussing lines and angles. Let's talk about parallel and perpendicular lines. There we go. Parallel and perpendicular lines. So we talked about parallel lines just a while ago. Parallel lines are those which have a fixed distance between them and they never meet each other. They just keep on going in. Keep on going. They keep on running parallel to each other, and the distance between them stay fixed. Let's say the distance between them is, let's say, 2 centimeters or whatever. These are parallel lines, right? Now, what about perpendicular lines? Perpendicular lines are those which meet each other at an angle of 90 degrees. These are intersecting lines, but they meet each other at an angle of 90 degrees, right? So for example, this is line PQ and this is line AB. How do we represent that these lines are parallel to each other? Well, we say line PQ. We draw these two lines, which means that PQ is parallel to AB. Or AB is parallel to PQ, really means the same thing. Let's give it a name. For example, XY and FG. So I'm going to say, these are perpendicular lines, by the way. Let me give it a name. Perpendicular lines. And so we're going to say FG is perpendicular. This is a symbol for perpendicular. Okay, I'm going to draw this. FG is perpendicular to XY. Okay, perpendicular lines are those which intersect each other or meet each other at 90 degrees. Okay, these are parallel and perpendicular lines. For example, draw a diagram to show RS is perpendicular to AB. Well, this is a line segment. This is a line segment. So I'm going to draw RS and AB. I'm going to say this is R and S. This is AB, and you can tell they are at an angle of 90 degrees. You can draw them. You can draw them like this as well. You can draw them like this as well. As long as the angle between them is 90 degrees, right? Their lines would be perpendicular. These are again line segments, parallel. So CD is a line segment. CD is perpendicular to OP. Remember, line segment is where you don't have arrows. This is a line. Okay, this is also a line. I'm going to draw two lines which are, again, perpendicular to each other. So I'm going to draw, I'll draw it differently. I'll draw it like this. Okay. But the difference is these lines are, these are lines, they're not line segments. Okay, I hope you can tell this is an angle of 90 degrees. Yes, it can pass along. It doesn't have to stop over here. It can cross the line as well. As long the angle is 90 degrees, the line is going to be perpendicular. Okay, so we're done with parallel and perpendicular lines as well. Let's talk about angle properties. Right, so we have three really important angle properties. The first one is called angle on a point, right? So let's say you have a point. All the angles around this point, let's say you have this angle A, angle B, angle C, angle D, E, F, G. You can have as many angles as you want, as long as they are around a single point. They all add up to give 360 degrees. A plus B plus C plus D plus E plus F plus G plus H. They all add up to give 360 degrees. Angles at a point which means one complete rotation, and that's 360 degrees. Next, we have this angle align. Okay, so whenever we draw a straight line, remember the angle on a straight line is 180 degrees, right? So if I were to split the angle, let's see if I were to draw another line. Let's say this angle is 45 degrees. How much would the rest of the angle be? Well, you could say, let's call this X, and we know that all of these angles add up to give 180 degrees, right? So you can say X is one angle, the other angle is 45 degrees. If you add them, you're going to get 180 degrees, right? So you can isolate X, sine 45 over to the other side, it becomes negative 45 degrees, 180 minus 45 degrees. Once you work that out, that's going to be the angle of X. Make sense? These angles are called supplementary angles. The name is really important. These angles are supplementary angles. Okay. If you look here, can I say that angle STU, which means the yellow angle, can I say angle STU? I'm going to put a cap on top of T because T is in the middle. And angle UTV. This is what we mean by angle UTV. Angle UTV. Angle STU and angle UTV are supplementary angles. How are the supplementary angles? Because they add up to give 180 degrees. Okay, you have 79 degrees, 101. If you add both of them, 79 degrees plus 101 degrees, if you add them, you're going to get 180 degrees. So definitely they are supplementary angles. Okay, simply supplementary angles are those which add up to 180 degrees, right? Supplementary angles are those which add up to give 180 degrees. Now we'll talk about angles in a right angle. We already know that a right angle, by a right angle, we mean a 90-degree angle, right? Now, if I were to split this right angle into any number of angles, for example, I can split into two angles, right? Now, one of them could be 45 degrees, the other one can be 45 degrees, right? Then these two angles are complementary angles because they add up to give 90 degrees. Or I can split it this way. I can split it into 30, 60. So for example, you can say, well, this is 30 degrees. Sorry, this is 60 degrees. And let's say this is 30 degrees. Then this 30 and 60 degrees are complementary angles to each other, right? So what do we mean by complementary angles? Angles that add up to give 180 degrees. Let's say this is angle A, this is angle B. Sorry, add up to give 90 degrees. This is A, this is B. If you add them, A plus B, you're gonna get 90 degrees, right? So angles in a right angle are called complementary angles. Complementary angles, and roughly speaking, angles that add up to give angles that add up to 90 degrees. Those are complementary angles, right? Find a size of the angle that is complementary to 15 degrees. So what it actually means is, let's say you have a right angle, right? And the right angle is split into 15 degrees and the other angle, right? One of them is 15 degrees. What about the other angle? I do not know. So what I will do is I will say that, okay, one of the angle is 15 degrees, the other angle is, let's say it's A. If you add them, you're going to get a 90 degrees, right? Then A is going to be 90 degree minus 50 degrees, and you will get your answer. Similarly, you'll do the same for 87 degrees as well. You'll do 90 minus 87 degrees, and you will get your answer. Similarly, 90 degrees minus 43 degrees, and you will get your answer for the complementary angles. Okay, now we have another question which is on supplementary angles, right? Supplementary angles are those, again, which add up to give 180 degrees, right? On a straight line, angles on a straight line. So if one of the angle is 129 degrees, 129 degrees, how much would the other one be? Talking about this one. How much would the other one be? Well, you will have to subtract it from 180 degrees and you will get your answer. Similarly, for 57 degrees, I'll do, for supplementary, I'll subtract from 180. For complementary, I'll subtract from 90. 180 minus 57, and you will get your answer. Similarly, this is pretty simple, 90 degrees. So what it actually means is split in half, right? Split in exact half. So if one of them is 90 degrees, of course, the other one is also 90 degrees. Okay, so that they can add up to give 180 degrees. You can do an 80 minus 90, and you're going to get a 90 degrees. I hope it makes sense. Find the value of the unknown angle using a protractor. So we know this is a right angle triangle, right? One of the angles is 38 degrees, the other one is x. I'll say x plus 38 should be equal to 90 degrees, right? To find out the value of x, you should do 90 minus 38, and you will get the value of x. Now, uh, this may sound as confusing, but take a look. This is x, this is x, this is x, right? I do not know what these values of x are, but what I do know that they're all the same, right? So if I add x plus x plus x, they all should add up to give 180 degrees, right? So if you add three x's, you're going to get a 3x. I'm sure you've done this in algebra. X plus x, do not make it x cubed, it's actually 3x. 180, x is going to be 180 by 3, which is 60 degrees. Okay, talk about this one. So we know, we talked about a while ago, angles on a point, right? If you have this point, then all the angles around it add up to give 360 degrees, right? So you have this one angle, 120 degrees, right? This angle is not really mentioned, but we can already tell since you have a small square over here, this is 90 degrees, right? 120 degrees plus 90 degrees plus, I do not know what the value of A is, so I'll call it A, and all of them should add up to give 360 degrees, right? From here, you can work out 120 plus 90 would be 210, right? So this would be 210 plus A is 360. A would be equal to 360 minus 210, and you can do the math and get your answer. I hope it makes sense. We'll do the same thing over here as well. So this is 209 degrees, right? This is 101 degrees, and the last one is S. I do not know what S is, but what I do know is S plus 209 plus 101 equals 360 degrees, right? So 209 plus 101 would be 310 equals 360. I will move 360 over to this side. Sorry, 310 over to this side. So it's going to be 360 degrees. Do not forget to put a degrees on top for all of these angles. Minus 310 degrees, and you will get 50 degrees as your answer. If we can do this, I'll just form the equation for you. I'll let you do the rest. 146 plus 69 plus 30 plus B should be equal to 360 degrees. And you'll do it the same way as we did before. You could just add these numbers, subtract it from 360. Similarly, I'll do the same over here as well. I'll start from here. You can start from anywhere you want. 131. I can start from 103. Totally fine. 103 plus M plus 131 plus 95 equals 360. And once you have that, You can work out the rest of the numbers by yourself. This is my unknown. This is what I need to find out. M, and over here, P is the unknown. Cool. So this is about three types of angles: angles on a point, angles on a line, and angles in a right angle. Okay, so we're done with angle properties. Let's talk about angles on parallel lines. What are the types of angles on parallel lines? Well, let's say you have parallel lines. These are parallel lines. I'll draw it this way. These are parallel lines, and these are parallel. This is a set of parallel lines. Now, if I were to run a line, if I were to make a line that cuts through the parallel lines at a certain angle, this line is called a transversal. Okay. Now, at this transversal, a bunch of angles are equal to each other. Okay. You have to analyze it very, very carefully that um, this angle, the angles that form a Z, I'll tell you what I mean by that. The angles that form a Z are called alternate angles. Let's talk about alternate angles first. So we also call them Z angles. Okay. Now, as long with the transversal is cutting the parallel lines, try to form a Z. Try to make a try to see if you can make a Z. I'll draw this line again. If you can form a Z. So what I can see is this is a Z, right? Now the inner corners, the angles in the inner corners of the Z, let's call it A. Let's call this angle B. Angle A is equal to angle B. Okay. Z angle is also called alternate angles. Okay. Now here's another example. Let's say that these are parallel lines. If a transversal cuts through these lines, a Z can also form like this. This is also kind of a Z. All right. And this, of course, the angles in the inside of the Z, A, let's call this. Let me name it differently. Let's call it angle P. Let's call it angle Q. Angle P is equal to Q because they are Z angles, or the proper name for them would be alternate angles. Okay, now let's think about this pair. If I were to, in this question, if I were to form a Z over here, right, which angles are alternate pairs? Angle B and angle A, right? So A and B are, we'll name them as alternate angles. Can I form another Z? I can try forming an opposite Z, for example, here, right? Then there is the angle D, but there is no angle here. Okay, so we'll say they're not really. I don't think there's any other pair of alternate angles here. A and D. A and D are co-interior angles. D and E are vertically opposite angles. A and C are F angles. Yep. Okay, I hope you can realize there is a set of alternate angles here. Then there's another type of angles in parallel lines. We have three types of angles in parallel lines, actually. One of them are called, so we've talked about one, which are alternate angles. Alternate angles. The other ones are called corresponding angles. One sec, let me put some space over here. More space. Okay. And the other ones are called corresponding angles. Corresponding angles. Corresponding alternate angles are called Z angles. Corresponding angles are called F angles. So the angles that form an F on a parallel line. I'll tell you what I mean by that. Here's a parallel line, right? A transversal that cuts through these parallel lines like that. All right. Then the angles that form an F. Take a look. Do you see this? Right. Then these angles would be called alternate angles. I'll call it angle A, angle B. Then angle A is equal to angle B because they are corresponding angles. Okay, I'll give you an example. Similarly, on the same parallel lines, if I were to make another F, there's an F. Just like the angle above is equal to the angle above, similarly, the angle below is equal to the angle below. CD. They're also corresponding angles. C equals D. They are also corresponding angles, right? Whenever you're analyzing angles, make sure they look equal. Okay. They they look that like they have the same level of opening. They both have the same level of opening, so there's definitely corresponding angles, right? I'll give you another example. You can draw the F the other way around as well. Okay. This F can also work this way as well. This is also an F. Okay. So outside is equal to outside. I'll call it angle P. I'll call it angle Q. P is equal to Q. Why? Because they are corresponding angles. Okay. On the same diagram, I can spot another set. Here, X and Y, right? X equal to Y. Why are they equal to each other? Because they are also corresponding angles. I guess I hope the F angles and the Z angles make sense. These are the angles on a parallel line. There's also one more, and those are called co-interior angles or allied angles. One sec. Co-interior or allied angles. Now this is different. Okay, they're angles on a F, but a little differently than you would expect. So let me name a few angles here. If this is, let's say this is angle A and this is angle B, they're equal to each other because they are corresponding angles, right? What about this angle, A and B? First of all, do they look equal to each other? I don't think so, because this angle is less than 90. This is acute angle. This angle is definitely bigger than 90. So this is obtuse angle, right? So they're not equal to each other, but they do share a single property, and that is they add up to give 180 degrees. Yep. Allied angles or co-interior angles, if you add them, they're going to get 180 degrees. So can I say that allied angles are supplementary? Because we just talked about it a while ago, that supplementary angles are those which, when you add them, you're going to get 100 and supplementary angles are those which add up to give 180 degrees. So allied angles or co-interior angles are definitely supplementary to each other. Okay, over here, I hope you can tell this is an F, right? So angle A and angle C, they definitely look equal to each other. They are, wait a sec. No, there's not even parallel lines. These lines are not even parallel to each other, right? So we cannot name any angles as alternate angles or anything. Yeah, these lines are not parallel to each other. But what I can do is angle A and D. Hmm. Angle B and C, I can say that they're vertically opposite angles. B and C. Well, there is nothing about B and C. E and D. Yeah, D and E. Yes, they're vertically opposite angles. Do you see these angles? Angles on a cross are called, if you have a cross, then angles on the opposite sides of the cross are called vertically opposite angles. A and B. And then A and B are called A and B are vertically opposite angles. Cool. Right, working in alphabetical order, find the unknown values. Let's work in alphabetical order to find out the unknown values. So be very, very careful here that this is a parallel line. This is a line parallel to this. Okay. Now, which means this is a transversal that is cutting these parallel lines. Sec. Oh my God. Okay, this is a transversal that is cutting these parallel lines. This one, this one. Okay. If this is a transversal, then let's form a Z in our heads. So if I were to form a Z like that, then angles inside the Z, which means C will have the same value as A. Okay, let me just put it over here. Angle A is the same thing as angle C, right? And let's talk about the, do we have any, these are also into parallel lines. And the double parallel lines that you see over here, these and these, they're also parallel lines, right? And this is a transversal that is cutting through them. Okay, so if let's form a Z around it. So this is a Z I can form, right? So if that's a Z, then A is the same thing as 40 degrees, right? So this is our first finding. The second finding is A equals 40 degrees, right? If A is equal to 40 degrees, C is also equal to 40 degrees, right? So C is 40 degrees. Let me write this over here. C is 40 and A is 40. What else? I think we can already tell this if this is parallel, right? And if this is making an angle of 90 degrees with the bottom, then this angle should also be 90 degrees, right? So you can say that um, angle D is equal to 90 degrees. Okay, let's put this over here, 90 degrees. Aren't A and B equal to each other due to angles on a cross, vertically opposite angles? If I were to draw a cross over here, then A and B, aren't they equal to each other? A is equal to B because they are vertically opposite angles. Okay, whatever the angles you're equating each other to, give them names. Give it a reason why. So vertically, no, A is equal to C because they're alternate angles, right? So if A is equal to 40 degrees, C is also equal to 40 degrees. So far we have the value of A, C, and D. And A is the same angle as B because they're vertically opposite angles. So which means if A is 40 degrees, B is also going to be 40 degrees. So let me put this angle over here. This is 40 degrees. Can you work out F? Okay, think about it. This is a straight line, right? And on a straight line, you have one of the angles is D, which we know is 90. Wait a sec. Which we know is 90 degrees. One of the angles we know is 40, right? Which is angle A. What about angle F? I think you can already tell that they're supplementary angles, right? So 90 plus 40 plus F is equal to 180 degrees because of the reason that they are supplementary angles, right? Let me write this over here. Supplementary angles. So F should be equal to 90 plus 40 is 130 plus F is equal to 180. F should be equal to 180 minus 130, and F is 50 degrees. So we've got the value of F as well, that is 50 degrees. What's left? Let's see. If these are, okay. Now let's consider parallel lines one more time. This is a parallel line and this is a parallel line, right? This is a line parallel to this. Now, this horizontal line is a transversal, right? This is a transversal. Then angle G is the same thing as angle F because they're corresponding angles. Make sense? Angles on an F, right? This, I hope you can see an F being formed. I'll use a different color. I hope you can see an F being formed, right? So this angle F is the same thing as G. F is equal to G because they are corresponding angles. I know this is one of the tough questions. Uh, so F is equal to F is the same thing as G because they're corresponding angles. We already know F is equal to 50 degrees. So G is also going to be 50 degrees. Do we have all the angles? I really hope so. G is equal to 50 degrees. I think are we good? We have A, and we have C, we have D, we have B, we have F, and we have G. G is equal to 50 degrees. A, B, C, D. Do we have angle E too? Yes, there's an angle E. Um, Angle E is visibly 90 degrees, isn't it? Because it's the vertically opposite angle of 90 degrees. Okay. So you can say D is equal to E because they are vertically opposite, right? Aren't the angles on a cross? This is a cross, this is a cross, right? So there are the angles on the opposite side of a cross. We already know that D is 90 degrees, so this should also be 90 degrees. If D is 90 degrees, so is E, and we have all the angles. I think A, B, C, D, and we have E, F, and G. We've worked out all the angles. Okay, we used just the properties that we've studied. We only use the properties that we've studied just now. Okay, find the unknown value. This is 62 degrees. This is also 62 degrees because of angles which are vertically opposite to each other, right? Angles on a cross. Interesting. This is M degrees. Then if you talk about angles on a cross, right? Then these two angles should also be equal to each other. So can I say that M is equal to 41 plus 70 because they're vertically opposite angles, and you can work out the value of M. 41 plus 70 is going to be 111 maybe degrees. Okay. Let's talk about this. 93 is the same thing as K plus 42. So I'll write 93 is the same thing as K plus 42. So if you want to work out the value of K, you could just subtract 42 from 93 and you can have the value of k. Okay, I think that's enough about angles. Let's move on to the next topic. Things are going to be easy now. Perimeter. Perimeter is really simple. Perimeter means length of outer boundary. Length of outer boundary. Okay. So if I mean the outer boundary, I'll just add all of these lines. 12 plus 10 plus 9. That's it. 12 plus 10 plus 9. If you add them, you're going to get your answer. Similarly, okay, whenever you see single dots, which means all the lines with single dots are equal to each other. So if this is 6 and it has a single line, a small cut through it, which means this is also 6, this is also 6. Okay, this is a thing that you have to be careful about when dealing with the shapes. So I think it's easy. 6 plus 6 plus 6 plus 11, you can have your answer. Similarly, okay, be careful here. This is 2.3 kilometers. This is 2.3 kilometers. This is 800 meters. This is 700 meters. Okay. So you can't just add them like that. You have to make sure that you're all in the same units. So I'll convert everything into meters because that's easier. I'll multiply it by 1,000. I hope you remember that. I hope you remember unit conversions: millimeter, centimeter, meter, and kilometers. Going from meter to kilometer is 1,000, so we multiply it by 1,000. And this is going to be 1,200 kilometers. Sorry, meters. Like it's already 800 meters, already 700 meters. If I multiply this by 1,000, I'm gonna get 2,300 meters. Now can I just add all of these numbers? 2,300 plus 1,200 plus 800 plus 700. If you add all of them, you're going to get your answer in meters. Similarly, this is pretty simple. If this is 5, this is also 5. If this is 3, the other one is also 3. You can just add them. 5 plus 5 plus 3 plus 3. And this is 7, and the opposite to 7 is this is 2. Right? This is 6, and this is 11. You can just add them. 11 plus 11 plus 6 plus 6. Make sure that you have your answer in centimeters. Next thing we'll talk about area. Area of a rectangle. Area of a rectangle is really simple. We talk about area of a rectangle. It's just length multiplied by breadth. I'm sure you've done this a lot in your in grade 7 or 8. This is length, and let's say this is width. So what I'll do is I'll do length multiplied by width, and I'll get the area. For example, this is a rectangle. Area is going to be 13 multiplied by 9. Okay. Now, the one thing is really important. You have to make sure that area is unit squared. Okay. What I actually mean by that is, um, this is 13 centimeter, this is 9 centimeter, right? 13 centimeter, and this is 9 centimeter. You're multiplying the numbers, right? 13 multiplied by 9, and what you'll get. But you're also multiplying centimeter and centimeter, right? So whatever the number you'll get, it should have centimeters square, because there's 2 centimeters that are being multiplied, right? Similarly, 1.5 multiplied by 0.8, if you multiply them, you get your answer in meters squared, because the unit is meters. A lawn bowls club has a green with dimension 40 meters by 60 meters. So this is 40 meters and this is 60 meters. 30 square kilometers can be mowed each minute. Find the area of the green. So let's find out the area. Area is going to be 60 meter multiplied by 40 meter. It is going to be 6 4 is 2400. M, if you multiply meters, it's going to be meter squared. Okay. How long, what is it? 30 square meters can be mowed in each minute. So in every minute you can mow 30 square meters, right? How much time is going to take? Well, your total area is 2,400 meters square, right? Each minute, in every minute you can mow 30 meters square. So time will be to if you work out the time, 380 minutes, I think. 80 minutes it's going to take, right? Because this is the total area, right? And it takes 30 minutes. It takes what am I saying? It takes 1 minute to mow 30 square meter. So how long would it take to mow the whole green? Of course, you'll divide it by 30. You're going to get you can double check your answer. I'm not very good with calculations. Next, area of a triangle. Now, area of a triangle is a little tricky. You have to be very, very careful. The formula for the area of triangle sounds very simple, but at the same time, it's very deceptive. A half multiplied by base multiplied by height. This is the formula for the area of a triangle, right? Now let's talk about the base and a height. If this is the base of the triangle, then the height is going to be, this is going to be the height, right? If this is the base, then the other one is the height, right? If this is the base, so this is the base of the triangle, then this is the height. Okay, but the height doesn't have to be in the, in the through the middle of the triangle, or maybe a line of a triangle. The height can also be outside of the triangle as well. Okay, so this is the base, right? Okay, and the length of the base would not change, and this would now be my height. Okay, so now once you have the base and the height, you can just put it in this formula, a half times base mod times height, and you will get the area of the triangle. Makes sense. Let's do a bunch of questions. So for example, in this one, this is the base, right? And this is very clearly the height. So area is going to be a half, base is 6, height is 5, 6 5s are 30, divided by 2 is 15 centimeters squared. Make sure that you're putting, if it's area, make sure you're putting in square. In this one, half, this is the base and this is the height. So half times 10 times 6.8, this is going to be 34 centimeters squared. Okay, so be very, very careful while solving these. This is the base, 2 meters is the base, and 13 meters is the height. Okay, be very, very careful while doing this. 2 meters is the base, 13 meters is the height. Do not add these 5 meters into it. Do not do that. So area equals a half, base is 2, height is 13, and this is going to be 13 meter square. For this one, this is going to be the base. Yeah, for this one, let's do this one first. For this one, 28 meters is going to be the base, and 15 meters is the height. So area is going to be a half, base is 28, height is 15 meters. So 15 meters is going to be the height. Let's talk about area for trapezium. What is a trapezium? Let's first talk about trapezium. Trapezium is a shape. It's a quadrilateral. First of all, we're doing the quadrilateral. A quadrilateral is a shape that has 4 sides. So trapezium is a 4-sided figure that has at least 2 parallel lines. At least a set of parallel lines. Okay. Trapezium can have any shape. As long as it has 2 parallel lines, it is a trapezium. I'll give you an example. Take a look. If I were to draw a shape like this is a trapezium. Why is this a trapezium? Because first of all, it has 4 sides and it has parallel lines. Okay. Make sure that it has a set of parallel lines and it has 4 sides. Now for the area of trapezium, area equals a half a plus b multiplied by h. This is the area. Now what is a, what is b, what is h? A and B are parallel lines, and H is the distance between them. Okay, so let's say this is 5 and this is 3, and maybe the distance between them is 2. The formula is going to be 1 over 2. Parallel lines A and B are parallel lines, so I'll add their sum, 5 plus 3. Multiply by distance between them is 2, so I'll multiply it by 2, and you can work out the area. 2 will cancel out, 5 plus 3 would be 8, area would be 8. Whatever, it could be centimeter squared, it could be millimeter squared, depends on the units. Okay, let's apply the formula to this one. First of all, let's part the parallel lines. Here's the parallel lines, 9 and 12, right? And the distance between them is 4. So I'll apply the formula, 1 by 2, base multiplied by height. Sorry, for trapezium, it's sum of the parallel lines, 12 plus 9 multiplied by 4, right? So this is going to be 12 plus 9, you can work it out. And the answer is going to be centimeter squared. Similarly for this one, I hope you can tell the parallel lines, parallel lines, parallel lines. So that's going to be 1 over 2, 8 plus 5, and I'll multiply it by 2, because 2 is the distance between them. This is A, this is B, this is H. Okay, over here, this is a parallel line, this is a parallel line, and the distance between them is 6. So area will be equal to 1 by 2, 11 plus 3, and I'll multiply it by 6, and you will get your area in centimeter squared. So that is for the area of a trapezium. Let's take a look at this question. Joanne is using a trapezium-based piece of material to make a skirt. Find the area of the material in meters squared. Let's find out this area. So I hope you can tell. This is a parallel side, this is a parallel side, and the distance between them is 0.8 meters. Now be very, very careful, the units are not the same. This is 0.8 meters, right? Let's convert it into centimeters first. So this is going to be 80 centimeters, right? I hope you remember millimeter, centimeter, meter, and kilometers. So if you're going backwards, then you multiply it by 100. So 0.8 multiplied by 100 would be 80. Similarly, 1 meter multiplied by 100 is going to be 100 centimeters. Okay, we need to find the area in meters squared, which means everything has to be in meters. Okay, so we'll convert everything into meters. My bad. This is meters, this is good, this is meters, this is good. Let's convert this into meters. Centimeter to meters going forward is division. 76 divided by 100 will be 0.76 meters. Let's find out the area. So 1 by 2, sum of the parallel sides, I'll add them. 1 plus 0.76 and multiply it by the distance between them. And you will get the area of this trapezium in meters squared, because everything is in meters. The material is worth 16 per square meter. Find the total value of the material. So 16 per square meter. Let's say your area turns out to be 1.2 meter squared, let's say, right? The cost is going to be 1.2 multiplied by $16, and you're going to get the cost of the entire material. Whatever is the area, just multiply it with the cost, and you will get your total value of the material. Volume, I've kept volume really, really simple. I've only in this, I'll only talk about the volume of a cuboid. Okay, so volume of a cuboid. Cuboid is, think about cuboid as a 3D rectangle. So volume of a cuboid is length multiplied by breadth multiplied by height. Think about it as a carton or as a box. This is length, this is width, this is height. Let's multiply and see W. Find the volume of this rectangular prism. Well, you have length is 85 centimeters, width as 6, height is 24, so volume is going to be 8.5 multiplied by 6 multiplied by 4. You're going to get a volume. A really important thing is that for volume, you keep the unit as a length cube. So this is centimeter. You're multiplying centimeter 3 times, right? So it's going to be centimeter cubed. Be very careful about that. Which chocolate box has a larger volume? Well, we'll calculate the volume of each one. This is a chocolate bar, 23 multiplied by 14 multiplied by 2. You're going to get a certain number of volume in centimeter cubed. And then for this one, it's 5 centimeter multiplied by 6 centimeter multiplied by 22. We're going to get a certain centimeter cube. Then you can compare which one is bigger and which one is smaller. And that's